Can I get a motion to approve the meeting agenda?
Motion.
Yes. Right on time. Get a second to approve the agenda?
This is Keith, I'll second.
And could we get a vote? Guess we don't have to have a roll call anymore, do we? Yeah, I missed that.
I missed that long
You know,
preamble, right?
I know when you call her name, I know mine's coming right after, now it's no fun. Anyway, everybody approve the agenda?
Yes. Approved.
Okay, let's go for the first action item. The approval of professional design services contract amendment.
Good morning, everybody. So I am here to seek approval for the professional services contract amendment for the Reservoir Park project. Just start off with a little bit of a project background. The design contract was approved back in November of 2018. We started our issue NTP to Nelson Bolts and subs shortly thereafter in 2019. When the design contract was initially approved, it was $860,000 was authorized with no contingency, and the contract included the design, permitting, and bid phase services for the Reservoir Park project. And initially, it was a 16-month design schedule. Obviously, there are quite a few factors that played into extending that.
Can I interrupt? I have a question. Why did we approve that with no contingency? Just curious.
I think there was a lot of back and forth and background on that. I think the board just wanted oversight on all the spending that was going to be included on this project. So I guess that's sort of the best as I recall. There was I guess, concerns about the budget that was allocated.
It's a design contract, right?
Yes, design, permitting, and bid phase services, though.
That puts the general manager in an awkward position if she wants to keep things moving. Okay, just a question. Go ahead.
Mr. Sultan, if I could just add to that, I think at the time, when we were talking about doing a park, there was a lot of discussion about Loud and Water's involvement in that park and things like that. But, and so when this contract amount came forward, there was some discussion about how high it was, I guess. And so the discussion was more around, certainly this should be able to be completed with $860,000. So no contingency was awarded. And it's gotten a little, it has been hard kind of to manage because there have been requests along the way and things that we've added. So that's why we're here today to ask for some additional funding.
Mr. Sultan, if I may, I wanted to add, I wanted to commend Stefan for his management of this contract. I think you'll see here in a future slide that, some of the excess spending, was work that was, added scope. And I think he's done an excellent job managing this contract through its life. And I really wanted to commend him for that work.
Yeah, no, I'm not criticizing that. I'm just,
Absolutely.
I mean, it's not normal that we approve something without a contingency,
Certainly.
which makes her job harder. Or your job harder too. Okay, go ahead.
Yeah. So as Alan was alluding to, there were a couple out of scope items that have occurred over the past, 2 years of design phase. As you can see on the screen, I'll sort of step through each one of them. First starting off with the renderings and some architectural workshops with the board. These were requested just in order to give the board a little better feel on the aesthetics of the finishes for the structures. We went over, colors, materials, how it was going to be attached to the buildings, cladding, things of that nature. And this was mostly done at the Water Resources Committees. Both Nelson Bolts and Studio 27 put a lot of time and effort into this, developing slides, preparing renderings, and they also attended the workshops in order to answer the board's questions as best they could. Looking at the next bullet point, we did some value engineering of the site utilities. This occurred once we got a little better understanding of the costs associated with the project. As we continued to develop the design, we got much more refined cost estimates, much more granular cost estimates that allow us to really pinpoint where a lot of the costs were stemming from, and we were able to look at some of the bigger ticket items and worked with Bowman to value engineer and sort of redesign some of these site utilities and bring down the construction costs quite a significant amount. There's also some additional bid evaluation and value engineering that occurred. This was after the first bid opening. As you all recall, the bids came in quite a bit higher. So the design team worked with FHP, who was the parent low bidder at the time, just to get a better understanding of why these bids and our estimate were so far apart, and try to identify ways that we could, bring down the contractor's costs. And then lastly is the rebidding of the project. Right now, we're working towards re-advertising this project. The goal is to get it out next week and hopefully bring it to the July board for approval. So we're working with the consultants to, incorporate some lessons learned. Any addenda that were issued during the first bid phase are going to be added to the project. And also there's some bid phase services for the consultants in there in case any additional questions come up during this second bidding process. So those are all the out of scope items that we're here to talk about today. And with that, we do have a breakdown for each of these sort of line items here. And I won't go through each line, but you can see the consultant, the scope, and the fee, or associated fee for each sort of task or overage that was incurred during the project, which amounts to just under $79,000. I will note that bottom row you see for Nelsonburg Volts, the rebid services is an allowance. It's $25,000. It will be billed on a time and materials basis, not lump sum. So, it's going to be billed on actual costs incurred. So if we don't see a lot of questions come in during the bid phase, we're not going to be spending all of that money there. But we want to have that set aside just in case, so we're not coming back in another month or two to request a little additional funds. So that pretty much, goes over all of the cost overages breakdown. And, my last slide is just the recommended motion. Although I do want to mention that, over the past 2 years, Nelsonburg Volts has been great to work with. They've incurred a lot of, additional challenges and delays and things of that nature. They've handled them very well. So personally, obviously I'm biased, but I think this is very well warranted. And, all of these are for actual additional services, not to handle, any design overages that were incurred for scoped items. Mr. Moody, I see you have your hand up.
Yes, hi, Stefan. Just wanted, that previous slide, I saw the line item design rework utilities. Could you explain that in a little bit more detail, what that is?
Let me go ahead and go back to that if I can. So that's essentially what I was mentioning for the previous about the value engineering of the site utilities. This occurred about the 50% construction documentation phase. After we got some cost estimates from CCI, we saw that the site utilities was a pretty large and I think slightly unexpected portion of the budget. So we went and worked with Bowman on that to, find new alignments for, mainly water and sewer, try to figure out different ways to tie in and how that would impact the project. We found a new alignment and we were able to get that incorporated into the updated design documents. So
Okay.
that's sort of where that cost comes from.
All right, thank you.
Yeah. Mr. Kopus?
Yeah, Marty, can you put this on the action agenda? Because I have to recuse myself from this item and I want to be able to vote on the consent agenda as a whole.
Jim, I prefer to be at the meeting.
Yes, I'm on this track. So we're asking to be, approve this without any contingency again. That present a problem?
We hope it's not a problem. We hope it's not a problem. I think, the bulk of what we're asking for here is that additional work that Nelson Birdwaltz has already done. And the goal is for that 25,000 to cover any, services during this rebid process. By that time, we're really done with design and then we move on to construction. So, we feel pretty confident that, that we can make it work with this amount. But again, the majority of that is for work that's already been done.
Yeah, I
So
think-
actually, the 25,000 is almost like a contingency.
It really
Set.
is.
Mr. Sultan, sir, would you make sure your mic is either on or it's closer to you so that we can hear and pick
It's
up?
on
the
green.
recording? Okay, maybe slide it a little closer to you so that we can,
Mean I should talk a little louder?
maybe a little, sir.
It helps to be tilted down.
Thank you.
Are there any other questions? Hearing none, can I get a motion? No? I'll move that we accept the recommended motion. Do I get a second?
This is Angeline. I'll second that.
And everybody in favor?
Aye.
Aye.
Okay, that takes care of the first item.
And that's to action item, right?
Yes, sir.
Yes.
Yes.
Okay, thank you.
Next item is an award of construction contract for Raspberry Selma Water Treatment Facility pump upgrades.
Okay, so my second presentation of the morning is for the award of the construction contract for some upgrades at the Selma Water Treatment Plant. Just starting off with a little background, the Selma Treatment Plant is located just north of Leesburg, along that Route 15 corridor, shown by that star there. It serves the Selma Estates and Raspberry Falls communities. There are several wells located within the communities, and this treatment plant, receives groundwater from there, treats the groundwater, and distributes it to residents. The average daily flows are on the lesser side, anywhere from 0.05 to 0.3 MGD, so 50,000 to 300,000 gallons a day, with a peak design flow of about 0.5 MGD. And sort of some of the issues we're seeing now is that the current booster pumps that distribute water to the residents and help maintain flows and pressures after the water is treated are a bit oversized for these low flow conditions, which causes excessive pump cycling and just inefficient operation. So the scope of this work is we're going to have the contractor come in, and currently they're actually, it's the backup. There are 4 existing booster pumps. They're sort of blurred or shaded out now, but if you follow my cursor, we have one located here, second booster pump located here, third booster pump located down at the bottom of the screen. So I see some lag. And then the 4th booster pump is shown where these two new proposed booster pumps are going to be located. So what we're looking to do is demo one of the older, the 4th existing booster pump, which is actually a carryover from the, one of the original Selma construction and design projects. And so we're going to demo that booster pump and its associated appurtenances, so like pressure gauges, some piping, little valves. And we're going to install 2 new smaller booster pumps and variable frequency drives just to handle flows on that lower end of the demand. And on top of that, there's going to be some electrical and INC work to help facilitate the installation of those new pumps, running conduit, as I mentioned, tying in the new VFDs, and then, programming associated with, installing 2 new pumps, just making sure all the, the 3 existing pumps and the 2 new pumps will all work together flawlessly. Before I move on, I did want to mention a couple things here. We are getting rid of one of the existing booster pumps, but, with looking at the maximum demand, there is no issues or capacity issues here with serving flows of 3 booster pumps. based off of, the max day demand, 2 booster pumps is more than adequate to handle those flows. So that third is just essentially a redundant pump, which is, our typical redundancy in these situations. So no issues with the capacity on the high end there if we get rid of one of those booster pumps. And additionally, the station will remain online during the duration of construction. No interruptions to the residents. Obviously those 3 booster pumps are going to remain online and providing water. So the residents in both those communities shouldn't see really any impacts associated with this project. So with that, I just want to go over a quick project timeline. We've been in design since about August of last year. Looking to issue NTP to the contractor hopefully here in June, and then construction will probably take us through the end of Q1 of 2023.
Stefan, Mr.
Yes.
Bonfils has a question.
Yeah.
Oh.
I have a question. You couldn't see my hand up. I enlarged the picture, so I just want to be sure I have a clear picture of what's going on here. So the current booster pumps are short cycling to maintain the street pressure. Therefore, that's impacting their life. So taking out the older one and putting in variable speed pumps means that those booster pumps will not come on unless higher flow requires it.
Right.
Is that correct?
Correct. Yeah, and and that's part of this. We'll do the programming for the pump station, but essentially, those larger booster pumps really aren't going to be needed unless we start getting into like the 200 plus gallon per minute range, which I mean during the summer isn't unusual, but during those maybe winter months, middle of the day type time frames, these 2 smaller booster pumps should have no issues sort of handling that.
Makes a lot of sense.
Mr. Koblis?
Yeah, Stefan, why weren't the new pumps that we just put in a couple of years ago installed?
Oh, you just muted yourself, Mr. Koblis.
Another rookie mistake. Yeah, how come the new pumps that were put in a couple of years ago weren't installed with VFDs so that we wouldn't have had to install these 2 little pumps?
I'm not exactly sure. I think I see Rick on the line who's actually part of the construction. I think there was a bit of uncertainty exactly what the flows might be. And it's not that these pumps can't handle the lower flows, it's just that they're a bit oversized. So even on sort of the low end, it's still not going to be an efficient operation there.
Okay, thanks.
So.
Yeah, Mr. Koblos, I'll add that it's the low end that these pumps are serving. The pumps that are installed there now kind of cover the high end or the high demand really well, but we need these additional pumps to cover the lower demand times.
Hi, this is Angeline. Just be a question here. First of all, we are covering the lower end, right? This is what you just said.
Yeah, so the goal of these 2 pumps would just to cover the lower range of the demands we see at this facility.
Why didn't we do that 2 years ago?
So I think when we initially constructed these upgrades, there was a little bit of uncertainty with the flows we might be seeing. We were obviously combining we were, I guess, combining the community, so to say, adding a membrane treatment facility. I think it was just at that point sort of unknown of how low flows we might be seeing at the time. So it was a bit of a new scenario. So at that end, we want to be covered for sort of the higher ends without exactly knowing what these low flow conditions might be. So I guess that's sort of the best answer I can give on that.
Mr. Sakar, I'll add, this was a.
I'm not done yet. Wait a second. One second. Please, excuse me, sorry, respectfully. So with the unknowns and the uncertainties, when we actually do, go into a project, we do classify and we do understand the unknowns and the uncertainties, right? So I understand that at that time, the uncertainties and the unknowns and the unexpectancies in general was not really taken into consideration.
Well, I think on that point, it's just, identifying risks and, trying to understand what the risk appetite is. I think the goal is here is always maybe be able to provide water to the residents, which is under the old situation that was able to be done. It's just that we're seeing it wasn't really done as efficiently as it could be. We were seeing just excessive wear on the pumps, and, which would end up reducing the overall life of each of these pumps. And, after we saw that, we were able to, find a better solution and still meet the needs of our residents. So, again, I might not have the exact background on some of this, the original design of the project, but I still think it's not that we didn't identify risks or didn't, adequately understand risk, is that our appetite for risk might be different. I see Kinsey's on video, so I'll turn it over to him now.
Hey, good morning, everybody, and hi, Mr. Sakar. So real quick, most of our small systems are maintain pressure in low periods through a hydro-pneumatic tank. The Selma system, about 500 connections, it's a little too big for the hydro tank. So whenever there's a demand in the system, our large pumps were running to meet that demand at all times. So these 200 gallon per minute pumps were running to kind of meet a 50 gallon per minute demand, and it was hitting the pumps just to the pressures. So it's really not an uncertainty or unknown. It's the fact of the use of the community. If during the night, if there was no periods, our pumps could rest and we would not be worried about short cycling. But we're not seeing that since the combining the two systems, if that makes sense.
Thank you for that explanation. But as far as I understand, that when we do a study, we always do a risk assessment, right?
We do.
We didn't do one for this one?
We did. I don't think this is really a risk. This is just extending the asset life. So these pumps are operating fine, but the wear components are wearing out much faster than we'd like. And that we do know that a smaller pump in this application is best suited to experience that wear. Selma, by itself is unique because it does have fire flow. So when we combine the two communities and we increase their capacities from about 500 gallons per day per connection to 900, that's just a huge more demand that we're ready to do. And that these big pumps do a great job meeting that demand in the summertime, but for most of the year, we do see lower periods. And to keep the system pressurized, we think that a jockey pump application versus a hydro-pneumatic tank application best suits our needs.
I understand the mechanical side, and I truly appreciate your explanation on that and, sort of getting us all up to speed to understand that. But I'm still kind of like, I'm stuck on the gear of risk assessment. So with this particular scope of work, have we done a risk assessment? Here's my concern. If we come back on the board later, what we don't want to hear is that, there are unexpectancies and uncertainties and there was no risk assessment done. Because it costs money in the end, right?
Absolutely.
Yep.
Yeah.
Ms. Ursakar, if I could, I think one of the things here is that we typically design these systems to meet maximum demand. And so that's what we did here. I think experience in this case is pointing towards a more efficient way to do it so that we can preserve the life of the pumps that are there. So risk assessment is done for every project. I think in this case, experience with combining these two systems together has then warranted a change in the way that we do it to be more efficient.
No, thank you, Carla. I appreciate that, but I hope everybody understands where I'm coming from.
And Ms.
And
assume
I'm
that
sorry,
the-
yeah, wait.
I'm sorry.
Sorry. I want to go back to him because I interrupted him and that's not nice. Go
Yeah.
ahead, please.
Well, just to complement what Carla was saying, and expand on the history of this facility, it was done as a very fast-track project to address goo contamination in some of the wells in the communities there. And so when you refer to risk assessment, in this case, I believe that would have been some of the hydraulic modeling and the assumptions that went into the design at that point in time. And when we were working through this project initially, we were again on a very fast track to protect our customers and move this project along as swiftly as we could. So what we're seeing here, again, to echo Carla, is a more efficient way of doing it that in the long run, I think saves us on the asset life and you know, on all projects, we do, you know, take the time to look at those risks. And, you know, in this case with the fast track and the combining of the communities and so forth, I think that likely factored in a bit here.
Thank you. I appreciate that. So I understand, and our demands are going to rise because we know Loudoun as a county, you know, is a rising community, right? The demands in terms of demand and supply, like demand is higher because, yeah, I understand that. Thank you. Marty? Yes, sorry.
I assume that there's no additional building going on in those projects, in those subdivisions.
I believe that's the case, Mr. Sultan. I think they're almost built out. If not, I'm not sure Kinsey is maybe a little closer to that, but perhaps at the time, again, you know, build out was still ongoing when this project was underway with design and construction.
And one other question, what do you do with the existing pumps? When you say you demo and just put them in for salvage, or are they reusable somewhere else?
I have to imagine that this particular pump, since we have 3 others, would likely be able to keep that as a spare.
Mhm. Yeah, so in the contract, we have it, you know, that the contract's gonna be required to, you know, deliver it to us, and then we can decide what we'd like to do with it. Depending on sort of, you know, when we demo equipment, and I guess not necessarily talking about this, we look at, you know, how old it is, how much of the remaining useful life it has, where these, you know, the same piece of equipment are used in other places in our facilities. So, and determine if it's worth storing or not. But for this specific piece of equipment, we have it at the contractor will be delivering it to us, and then we can make the decision on whether we want to keep it or get rid of it.
One last question for me is that the pump we're taking out is some of the last original equipment from the builder, the developer for the project? Is there any other aging equipment that we should be replacing?
So as part of this project, you know, I mentioned we're going to be doing some INC work. And so in our PLC cabinets, we're going to be sort of replacing some of the older components, some of the obsolete components, and upgrading them. And besides that, I think we're pretty set as far as equipment goes.
I was around when this was taken over. It really was a fast track project with a lot of pressure to get it done, and trying to keep the cost down. So using some of the other pumps that were perfectly good made a lot of sense.
So if there's not any more questions, I can go ahead and continue on. So as I mentioned, project timeline probably take us through Q1 of next year. So we advertised for bid in March and received bids a couple weeks ago, as shown here, with a low bidder being CPP Construction. You know, we reached out to them, discussed the project with them, made sure they were comfortable and had a firm understanding of the project, and they did. Additionally, they were at our pre-bid and site visit. After that, you know, we contacted the references and, you know, heard really good things about the company. In addition to that, we've actually worked with CPP quite a bit over the past several years, and they were actually the company who did the Selma expansion project that we've been talking about a couple of years ago. So they're very familiar with the facility, very familiar with its operations, and we're fully confident that they will do a good job on this project.
Hey, this is Angeline with CPP Construction Company. We did references, we checked references. We also took a look at, I think, I mean, that's what I don't understand. Have they done similar projects like this in the past? Have we worked with them before, or this is just, we're gonna be?
Nope, they've done quite a few projects with us, and they did the Selma expansion, 4 or 5 years ago at this point. So they actually worked on this exact, water treatment plant. In addition to doing several other projects for other municipalities that are, similar in scope.
Okay, thank you.
Yeah. So there are no really concerns about their, ability to do the work. We're very confident that they can get in and do a good job.
Are there any other questions? Can I get a motion to accept the recommended motion?
I'd like to make the motion, the recommended motion, place it on the consent agenda.
I second that. Can we get a vote? Everybody in favor?
I,
Aye.
Thank you for the presentation.
Yes.
Thank you.
Detailed answers.
Okay, the next is an information item, capital construction quarterly report. Do we have any? No, go ahead.
Michael, could you roll the slides back one for me? Thanks. All right. Good morning, everyone. My name is Rick Zafel. I'm going to provide the capital construction report for the first quarter of this year. And my agenda here, I'm going to talk a little bit about the Cortland permanent pump station, and then a little bit about the Trap Rock flow meter and sample line project. And we'll talk about the Broad Run expansion to 15 MGD, and then provide some quarterly summary numbers for our current projects, and then also the completed projects from the first quarter of this year. And so the Cortland connection to central system involved decommissioning the old wastewater treatment plant community system, and developing a new pump station and pipeline to connect the Cortland community to central service. And so this whole effort has been many years in the making, as there were multiple phases to develop that pipeline, as we built some segments and we repurposed other segments to complete the pipeline several years back. And then we built a temporary pump station in that time frame and decommissioned the old wastewater treatment plant. And now we're at the point where we are very close to completion of the new permanent pump station. And that project, as I mentioned, it involved, it's the final step in the replacement of the old wastewater treatment plant and connection of the community to central sewer service. And so on the permanent pump station project, it was awarded several years ago, in 2019. About $4 million contract value, and we are substantially complete with this project. I've got that photo there on your right, shows the completed pump station, the emergency storage tank, the odor control facilities, and then the new electrical building, and of course the demolition of the existing wastewater treatment plant is gone there. And then so on this project, the remaining work is really just some final punch list items and closeout. So we are at the finish line with this project, and there's a couple more photos there just showing some of the electrical improvements and the odor control facility and pump station. So hopefully this project will be on the completed list at the next quarterly update. And then moving on to the next project here, which is the Trap Rock flow meter and sample line project. The purpose of this project is simply just to improve operations related to disinfection and reporting. We awarded the project late last year, and the contractor is about 25% complete in terms of cost and dollars through the end of the first quarter. And then the graphic there on your right, the project really improves the flow of finished water from the clear wells to the finished water pump station, and then it also provides sampling ports for that water. And I've got some pictures here. So on the flow improvements, on the left is the old Venturi style restrictive flow meter that connected clear well 2 to the finished water pump station. And then on the right, you can see our new magnetic flow meter installed. And of course, the good thing is we've got full pipe diameter through that new meter for better flow from the clear wells to the pump station. And then my next pictures. Yes, sir.
Thanks for having somebody down in the well so we can get a scale of size of that. That's a big pipe. What is that, a 30 inch?
I think it's 30-inch or 36-inch pipe. Yeah.
Wow. Thank you.
And then we've also got just some photos here of just some of the trench work associated with the sample lines and the electrical and control infrastructure associated with the new flow meter. And this project is in the mid stages, and so, but it's a short project, so it may reach completion as well in the second quarter, but perhaps most likely the third quarter of this year. Okay. Moving on to the Broad Run expansion project. So this is kind of the highlight of the capital construction quarterly report here. This is, of course, the expansion of Broad Run from 10 to 15 MGD. Our contract value there includes the $1.5 million of change orders that we've experienced so far on the project. And the contractor is about half spent through the end of the first quarter, and they're just about halfway through the contract time to substantial completion at 47% through the end of the first quarter. So next month we'll actually pass through the midpoint of construction time-wise on the project. And then just our little index there still is tracking pretty good in terms of earned value versus planned value for the contractor.
I just have one thought. I guess the difficulty in getting equipment and deliveries and that sort of thing is not affecting it.
So I have that coming up here
Oh, okay.
on a slide, but yes, Mr. Sultan, we largely stayed ahead, not entirely, but mostly stayed ahead of the supply chain challenges with this project. And I'll have some more details here in just a couple slides on that. So one aspect of the project that has advanced really well is the yard piping. We're overall about 75% complete through the end of the first quarter on the project. I've got kind of a collage of pictures of some of the recent tie-ins of yard piping and wet taps and such. And so, you know, as we kind of come up out of the ground with the project, we're kind of on the tail end of the yard piping overall. Another aspect of the project I want to talk about is the improvements to the biological reactor basins. So at Broad Run, we have 3 biological reactor basins, and each one has 11 zones that are specifically geared toward nutrient removal as the flow moves through the basins. And one key aspect of that nutrient removal is aeration. And so what you see in the pictures there are the new diffusers and manifolds and PVC piping that supplies the air to those diffusers, which are a key piece of the nutrient removal. And so just to give you kind of a number there will be about 2,600 of these diffusers installed in various zones in BRB2, which is the one under construction at the moment. And then there'll be another 2,600 installed in the other 2 BRBs. And so there'll be a total of about 8,000 of these new diffusers installed in the BRBs, among some other improvements. And just real quick, you might be wondering what's the difference in color here in this picture on the left. The black colored diffusers have the actual fine bubble diffuser plate, membrane plate installed, and so that basically takes the air coming up from the bottom of the diffuser and disperses it into fine bubbles, and then the white colored ones don't have their plate yet installed. So everything is kind of in progress here in these pictures related to the diffusers.
Question on the diffusers.
Yes.
So the black ones, do they serve the same purpose as the white ones? That is, you know, removal of the nitrates that you talked about.
Yes, they do all serve the same purpose. All of them will have the black membrane plate, the fine bubble membrane plate installed. It's just that when this picture was taken, you know, things were the contractor was sort of in progress with installing the little plates. So every one of these will look like these over here with the black fine bubble diffuser plate installed.
Okay. All right. Thank you.
Mhm. Okay, another aspect of the project. Let's see if we can advance here. Michael, I seem to be stuck. There we go. Okay. Another aspect of the project that saw some good progress during the first quarter was equalization. So we completed the new 10 million gallon equalization tank in the first quarter. However, we're still working on the equalization vault there, which supports the tank and allows flow to go in and out of the tank. And so I've got a little picture here of the above ground portion of the vault. Of course, most of it is underground. It's about a 30-foot by 40-foot underground vault with some really large diameter pipe and valves in it. And then on the right side there, I've just got a picture from inside the equalization tank with a person standing there. And just some quick stats on the tank. It's about 240 feet in diameter. It's about 30 feet tall at the sidewall. And you're seeing the 30-inch diameter overflow pipe right there. And then at the dome of the tank, it's about another 20 feet tall, or about 50 feet tall at the center dome point in the tank. So a lot of good progress related to equalization in the first quarter. And then we'll move on. Okay. And then one more area of progress I just want to bring to your attention here is the building expansions for building 20, which is our core screen and grit removal building, and then building 24 here, which is our primary clarifier building. So this is pre-construction in the upper left. And then in the bottom left here, we've got the fourth quarter of last year. And so you can start to see a lot of new concrete forming out to the west of the primary clarifiers and then to the south of the screen and grit building. And then if we move up here to the first quarter of this year, end of the first quarter of this year, you can see even more concrete starting to appear in the clarifier and the screen and grit improvements. And then I've got a little bit better view of the first quarter progress here that I'll superimpose that shows a lot of the new concrete associated again with the screen and grit building in this area, and then the clarifier expansion in this area. Okay. And then some stats on the project. So submittal reviews, we've conducted about 1,200 submittal reviews on the project, and we're projecting about 600 more submittal reviews to complete submittals for the project. In terms of requests for clarification or requests for information, we've had about 284, and we expect approximately that many through the second half of the project. And then concrete. So the project includes a total of about 1,600 cubic yards, and we have placed or poured about 83% of that through the first quarter. And much of that concrete is associated with the building improvements that I shared on the last slide related to the screen and grit and primary clarifier buildings, and then also the equalization tank. Those three areas combined represent more than half of the total yardage of concrete on the project. Okay, moving along to the risk discussion and the supply chain. So we have seen some supply chain issues on the project, or delays on the project, just associated with ductile iron pipe fittings and also valves. And then we've also seen some related to HVAC equipment, particularly stainless steel cased HVAC equipment. Fortunately, these delays to the project have only impacted early delivery milestones, but not the overall finish date of the project. And just a couple of notes here. In our contract documents, we do address this topic in our general conditions with a kind of a no damages for delay provision where the contractor would be allowed an excusable delay for supply chain issues, but it's not compensable, not a compensable delay. The good news I mentioned before is that much of this project prices were locked in and materials and equipment were purchased before the supply chain issues really took effect from the pandemic. So we have minimal supply chain issues that we're dealing with on the project. And however they are impacting the schedule, as I said, but thankfully just the early delivery milestones and not the actual finish date of the project. And just a quick little anecdote I have on supply chain. So what you see pictured here is the last connection of 30-inch sewer pipe on the project. And what happened was the contractor ran out of pipe. They were 2 sticks short when they were constructing this. And so they basically stopped and demobilized, and they had to wait about a month or more to get just 2 sticks, 2 20-foot sticks of 30-inch pipe to then come back and complete this. And but right now, if a contractor, say, placed a new order of ductile iron pipe, it would be about a year before you could expect that pipe to arrive on site. So lead times have gone up for ductile iron pipe.
Rudy has a
Yeah,
question.
Yes, sir.
yeah, hi. I just want to ask, you mentioned there's no overall delay to the schedule. I'm just curious, is that because these task items were not in the critical path, or is there some measures that you took to address that, to change the schedule or mitigate the delays in the supply?
I think it's a combination of both the early delivery milestones that are associated with these delays. It's one particular milestone, and we call it milestone 5. It's not on the overall critical path. It does have an early delivery due date actually next month. It's in May of 2022, but it's not on the overall critical path, and so it doesn't affect the overall substantial completion date of the project, because that date is February 2024.
Okay. And you
So
mentioned there were some potential actions. I was just curious because, everyone's being affected by COVID and supply chain. So I didn't know if there was any lessons learned that could be passed on actions that were taken by the team to address those, or make modifications to schedule that would be beneficial to other projects.
yeah, well, I think the big thing on supply chain is that the contractor is entitled to an excusable delay with that, but not compensable. And so we haven't worked that out yet with the contractor related to this milestone 5 and the ductile iron pipe supply chain issue. So that will be worked out. However, knowing and anticipating that this was coming, we have worked with the contractor to kind of creatively shift work around to minimize the supply chain as much as we possibly can, during construction on the fly. So. But I think perhaps the lesson learned is when you're finalizing a project for advertisement in this time frame, you have to really survey the climate of material deliveries and time frame, lead times for equipment materials, and build that into your contract time and to your schedule, and also keep that in mind as you sequence a project as well. So I think that's kind of the lesson learned, looking forward to future projects.
Thank you.
This is Angeline, and
Yes, ma'am.
I heavily stress on this. This is a classic example that sometimes I put this stressor when I come on the board to talk about risk assessments. This is what you just mentioned is a classic example of how things projects get delayed. They are we don't there's constraints, there's roadblocks and obstacles, and I personally believe that they could have just avoided this to a greater extent. So not, it's just not very pleasing to hear that right now. But point noted, please, we want to avoid this kind of situation in the future. Even with the material, right? I mean, you kind of ran out of material, and now like you're going to have to wait a year for this, this project to complete, because the estimate on the material on the pipe was not well done. It was in blunt term, it was poorly done, because they were supposed to do this estimation, so.
Oh, Ms. Sursiker, I'm sorry we might have misunderstood. The delay for this pipe was a month, and I was saying that now, as things have worsened with the supply chain, it's a year. By all means, we're not waiting a year. It was just a month for us. So I'm sorry if you misunderstood or if I miscommunicated there. So we're not under that 1 year. That was just an anecdote for where the lead times are for ductile iron pipe. If we were to engage a new project and order ductile iron pipe, let's say 1,000 feet right now, we would wait a year for that ductile iron pipe to show up on a job site. That's sorry, that's how I meant to communicate that little anecdote. I'm sorry for the
Thank
confusion.
you. Yeah, thanks for the clarity and on my side too. Just one more question here quickly, where it says off note point number 1, where it says no damages for delay contract provision. What exactly does that mean?
So that is a provision in our general conditions of our contract, which says that if there is an event like a global pandemic or some act of God type event that happens to the project, okay, where it's no fault of any of the parties of the contract, no fault of the owner, no fault of the contractor, then that event constitutes an excusable delay to the project. So the contractor is entitled to a time extension, but they are not entitled to a contract cost increase for something such as extended overhead. So it's basically an excusable delay scenario.
Okay, so
Okay.
I don't like to use the word act of God, but
Okay.
natural causes that are beyond our
Sure.
control. Okay,
Sure.
thank
That's
you.
right.
Yeah.
Yes.
So the materials that you're getting, are they domestically produced or are they foreign?
It's a combination of both. In this case, the ductile iron is coming from Alabama for this project, so it's on the domestic side.
And on that too, I wanted to ask, and thank you, Marty. And what about the stainless steel? Is that coming from China, from Canada? Where is that coming from?
I think the stainless is coming from overseas. I think it's assembled in the U.S., but I think the actual raw metal comes from overseas. Yes.
Right. Yeah, that's why I didn't say, domestic, because I do know that very well that it makes a difference if it comes from China or from Canada. So that's the reason why I was asking, because it does really heavily impact the supply chain, particularly in a pandemic situation.
Certainly. Certainly.
Yeah.
Okay. All right. So just some key takeaways for the Broad Run expansion project. So communication between the parties remains good. Most of that is handled through RFCs or RFIs, request for information, shop drawings, and various notices. We're continuing to meet permit as we continue to construct the project and perform these retrofits to the plant. The contractor is maintaining good quality and they're addressing quality concerns or issues promptly as we work through the construction and come to the midpoint of construction here. And then, as I mentioned, the contractor is projected still to finish on time overall. And then last point here is that, there we go. Sorry about the quick shift there. We have 8 change orders executed so far on the project. We're averaging about 1 per quarter. 1 new change order per quarter. So most likely we'll be up to 9 change orders at the next quarterly capital construction report. Okay, some stats here on the existing construction projects here. So as I mentioned, the Cortland permanent pump station has reached substantial completion and it should be on the finished projects list by the next quarter. And then also the Howardsville and the Trap Rock flow meter and sample line projects are progressing nicely, and Howardsville definitely should be on the complete list next quarter, and the Trap Rock project will be close by the next quarter. And just over on the right side here of our table, just on the contingency utilization and change order percent numbers, we're tracking pretty good for all of these projects that are under construction. No red flags there. And then I'll step on to the completed projects from the first quarter of 2022. So there's 2 of them here, Sterling Valve Replacement Phase 3 and the Goose Creek Emergency Crossing. And just real quickly, final numbers on contingency utilization and change order percent turned out pretty well for those projects as well. And so with that, that concludes the first quarter report, and I'll be glad to take any questions that you might have or any other questions.
I don't have a question. I just want to thank you very much for your presentation.
Thank
Really
you.
appreciate it. Yes.
Yeah, I continue to be amazed at what you guys do with the percent of base contract and change orders. When I was with Fairfax, we never got that good. I could tell you that for a fact. So anyway, that was a good presentation.
Agreed.
Thank you.
The next item is a capital spending summary report.
Good morning, everybody. In the anchorman position, as usual, last on the agenda, we have the capital spending report through March, through the first quarter. Our actuals are tracking below our projected budget at this point, and if anybody has any questions, I'd be happy to see if I can answer them.
First of all, being the anchor man is not necessarily a bad thing.
No, it's not.
I thought it was a good thing. I don't know.
Well,
It sounds really impressive, like very masculine. I'm the anchor man. That's what I thought as a female on the board. Sorry.
the anchorman sounds good, but he's between us and beer, so
Ah, okay.
not really, but yes.
Is there no questions? I think we forgot in the second item to designate where we want to put it. It should be, I think it should be in the consent. The first item was in action.
You did.
The second one,
You were clear.
did we say it? Oh, okay, sorry. Okay. Well, it looks like there's no questions.
Our next meeting's on May 25th.
Next meeting is May 25th at 8 o'clock. I have a long trip, so I have to get up real early to get here.
You're here first.
I can walk here. Anyway, do I have a motion to adjourn? There are no other questions.
Without objection, then we adjourn.
I second. Having a vote? Aye.
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 Thank you, everybody.
Thank you. Thanks,
Okay.
everyone.
All right, take care, everyone.